Electric heating is any process in which electrical energy is converted to heat. Common applications include space heating, cooking, water heating and industrial processes. An electric heater is an electrical equipment that converts electric current to heat by means of resistors that emit radiant energy. The heating element inside every electric heater is simply an electrical resistor, and works on the principle of joule heating. An electric current through a resistor converts electrical energy into heat energy. Most modern electric heating devices use nichrome wire as the active element. The heating element, depicted on the right, uses nichrome wire supported by heat-resistant, refractory, electrically insulating ceramic. Alternatively, a heat pump uses an electric motor to drive a refrigeration cycle, drawing energy from a source such as the ground or outside air and directing it into the space to be warmed. Some systems can be reversed so that the interior space is cooled and the warm air is discharged outside or into the ground. Heat pumps can deliver 3 or 4 units of heating energy for every unit of electricity purchased, with the amount of heating energy delivered being a function of equipment efficiency as well as the temperature difference between the ground and the building interior. Space heating. Space heating is used to warm the interiors of buildings. Several methods of electric space heating are used. Radiative heaters. Radiative heaters contain a heating element that reaches a high temperature. The element is usually packaged inside a glass envelope resembling a light bulb and with a reflector to direct the energy output away from the body of the heater. The element emits infrared radiation that travels through air or space until it hits an absorbing surface, where it is partially converted to heat and partially reflected. This heat directly warms people and objects in the room, rather than warming the air. This style of heater is particularly useful in areas which unheated air flows through. They are also ideal for basements and garages where spot heating is desired. More generally, they are an excellent choice for task-specific heating. Radiative heaters operate silently and present the greatest potential danger to ignite nearby furnishings due to the focused intensity of their output and lack of overheat protection. In the United Kingdom, these appliances are sometimes called electric fires, because they were originally used to replace open fires. The active medium of the heater depicted at the right is a coil of nichrome resistance wire inside a fused silica tube, open to the atmosphere at the ends, although models exist where the fused silica is sealed at the ends and the resistance alloy is not nichrome. Convection heaters. In a convection heater, the heating element heats the air in contact with it by thermal conduction. Hot air is less dense than cool air, so it rises due to buoyancy, allowing more cool air to flow in to take its place. This sets up a convection current of hot air that rises from the heater, heats up the surrounding space, cools and then repeats the cycle. These heaters are sometimes filled with oil, which functions as an effective heat reservoir. They are ideally suited for heating a closed space. They operate silently and have a lower risk of ignition hazard if they make unintended contact with furnishings compared to radiant electric heaters. This is a good choice for long periods of time, or if left unattended. Fan heaters. A fan heater, also called a forced convection heater, is a variety of convection heater that includes an electric fan to speed up the airflow. This reduces the thermal resistance between the heating element and the surroundings faster than passive convection, allowing heat to be transferred more quickly. They operate with considerable noise caused by the fan. They have a moderate risk of ignition hazard if they make unintended contact with furnishings. This type of heater is a good choice for quick heating of enclosed spaces. Electric space heating is useful in places where air handling is difficult, such as in laboratories. Storage heating. A storage heating system takes advantage of cheaper electricity prices, sold during low-demand periods such as overnight. In the United Kingdom, this is branded as Economy 7. The storage heater stores heat in clay bricks, then releases it during the day when required. Water can also be used as a heat storage medium. Domestic electrical underfloor heating. These systems are called radiant heating systems, regardless of whether they include a heat exchanger or are electrically powered. When a home radiant heat system is turned on, current flows through a conductive heating material. For high-voltage radiant heat systems, line voltage current flows through the heating cable. For low-voltage systems, the line voltage is converted to extra low voltage in the control unit, and this low voltage is then applied to the heating element. The heated material then heats the flooring until it reaches the right temperature set by the floor thermostat. The flooring then heats the adjacent air, which circulates, heating other objects in the room by convection. As it rises, the heated air will heat the room and all its contents up to the ceiling. This form of heating gives the most consistent room temperature from floor to ceiling compared to any other heating system. Lighting system. In large office towers, the lighting system is integrated with the heating and ventilation system. Waste heat from fluorescent lamps is captured in the return air of the heating system. In large buildings, a substantial part of the annual heating energy is supplied by the lighting system. However, this waste heat becomes a liability when using air conditioning. Heat pumps. A heat pump uses an electrically driven compressor to operate a refrigeration cycle that extracts heat energy from the outdoor air or from the ground or groundwater, and upgrades its temperature to a level high enough to use for space heating. The working fluid boils at a low temperature, absorbing heat in an outdoor heat exchanger. Then the resulting vapor is compressed and condenses to liquid form in a condenser inside the building. Heat from the condenser is absorbed by the air in the building. In the summer months, the cycle can be reversed to provide air conditioning. Heat pumps may obtain low-grade heat from the outdoor air in mild climates. In areas with average winter temperatures well below freezing, ground source heat pumps are much more efficient than air source heat pumps because they can extract residual solar heat stored in the ground at warmer temperatures than is available from cold air. According to the US EPA, geothermal heat pumps can reduce energy consumption up to 44% compared with air source heat pumps and up to 72% compared with electric resistance heating. The high purchase price of a heat pump versus resistance heaters may be offset when air conditioning is also needed. Liquid heating, immersion heater. Water is most often heated electrically by putting a heating element in direct contact with it. Such an element is therefore called an immersion heater. The water to be heated is usually enclosed inside an insulated cylinder, a hot water tank. Such a heating element consists of a thin metal tube that contains an electrical resistance heater. This, in turn, is encased in an insulating material. To control the temperature of the water, a probe inserted alongside the element triggers a switch according to the temperature of the water, the system as a whole constituting a thermostat. Domestic immersion heaters. Domestic immersion heaters, usually rated at 3 kilowatts and on a 1.5 inches British Standard pipe screw plug in the UK, run on the normal domestic electricity supply, but consumers may also take advantage of a cheaper, off-peak electricity tariff such as Economy 7. In a typical off-peak installation, a lower immersion heater is connected to the separately switched off-peak heating circuit and an upper heater is connected to the normal circuit via its own switch. The consumer then has the option to top up the available hot water supply at any time, rather than waiting for the cheaper supply to turn on. A poorly insulated hot water cylinder will increase running costs because a consumer must pay for electricity used to generate lost heat. Electric shower and tankless heaters also use an immersion heater that is turned on with the flow of water. A group of separate heaters can be switched in order to offer different heating levels. Electric showers and tankless heaters usually use from 3 to 7.5 kilowatts. Industrial immersion heaters. Industrial immersion heaters can be either screwed or flanged. Screwed industrial immersion heaters, in the UK usually on a 2.25 inches British Standard pipe, are usually only rated up to approximately 24 a kilowatt, with 6 a kilowatt being considered the very top end that can be accommodated safely on a single-phase supply. Flanged immersion heaters can be rated at up to 2,000 kilowatts, or more, and require a three-phase supply. Against other means of heating water, electrical immersion heaters have a notable disadvantage. Water immediately adjacent to the heating element is heated to a temperature which is high enough to promote the formation of scale, commonly calcium carbonate, in hard water areas. This accumulates on the element, but over time, As the element expands and contracts through its heating cycle, the scale cracks off and drops to the bottom of the tank, progressively filling up the tank. This reduces the tank's capacity and, where the immersion heater is secondary to the heating of the water by a coil fed from a gas or oil-fired boiler, can reduce the efficiency of the primary heating source by covering that other coil and in turn reducing its efficiency. Regular flushing out of accumulated sediment can reduce this problem. Such problems can be avoided at the design stage, by maximizing the amount of hot element in the liquid, thus reducing the Watts density. This reduces the working temperature of the surface of the element, reducing the buildup of lime scale. Watts density should be 40 watts per inch 2 or below in hard water areas, but can safely be 60 watts per inch 2 where hard water is not an issue. Direct electric heat exchangers. The DEHE uses direct contact electric heating elements inserted into the A-O shell side A medium directly to provide the heating effect. Virtually all of the electric heat generated by the electric circulation heater is transferred into the medium, thus an electric heater is nearly 100% efficient. Direct electric heat exchangers, also known as circulation heaters, are used in a variety of applications. They are used to heat gases like nitrogen, hydrogen, and hydrocarbons as well as liquids such as water, oils, acids, solutions and other fluids. They are also used in a wide variety of industries, including crude oil refining, gas processing and transmission, chemical reactors, semiconductor, petrochemical, and pharmaceutical. Electrode heater. With an electrode heater, there is no wire wound resistance and the liquid itself acts as the resistance. This has potential hazards, so the regulations governing electrode heaters are strict. Environmental and efficiency aspects. The efficiency of any system depends on the definition of the boundaries of the system. For an electrical energy customer, the efficiency of electric space heating is almost 100% because almost all purchased energy is converted to building heat. However, if the power plant supplying electricity is included, the overall efficiency drops drastically. For example, a fossil fuel power plant may only deliver 3 units of electrical energy for every 10 units of fuel energy released. Even with a 100% efficient electric heater, the amount of fuel needed for a given amount of heat is more than if the fuel was burned in a furnace or boiler at the building being heated. If the same fuel could be used for space heating by a consumer, it would be more efficient overall to burn the fuel at the end user's building. Variations between countries generating electrical power affect concerns about efficiency and the environment. In France 10% is generated from fossil fuels, in Britain 80%. The cleanliness and efficiency of electricity are dependent on the source. In Sweden, the use of direct electric heating has been restricted since the 1980s for this reason, and there are plans to phase it out entirely. See oil phase out in Sweden, while Denmark has banned the installation of direct electric space heating in new buildings for similar reasons. In the case of new buildings, low-energy building techniques can be used which can virtually eliminate the need for heating, such as those built to the passive house standard. In Quebec, however, electric heating is still the most popular form of home heating. According to a 2003 Statistics Canada survey, 68% of households in the province uses electricity for space heating. More than 90% of all power consumed in Quebec is generated by hydroelectric dams, which have lower greenhouse gases emissions than thermal power stations. Low and stable rates are charged by Hydro-Québec Copyright Bec, the provincially owned utility. To provide heat more efficiently, an electrically driven heat pump can raise the indoor temperature by extracting energy from the ground, the outside air, or waste streams such as exhaust air. This can cut the electricity consumption to as little as 25% of that used by resistive heating and thus reduce the environmental impact. Electrical space heating can still be economic where electricity supplies are low cost. Where the primary source of electrical energy is hydroelectric, nuclear, wind, or other carbon-free source, grid electricity can be conveniently used since it is mostly not practical to exploit that resource directly in heating applications. Economic aspects. The operation of electric resistance heaters to heat an area for a long period of time is generally considered to be costly. However, intermittent or partial day use can be more cost-efficient than whole building heating due to superior zonal control. Example, a lunchroom in an office setting has limited hours of operation. During low-use periods a monitor level of heat is provided by the central heating system. Peak use times between the hours of 11 o'clock (14:00 are heated to comfort levels. Significant savings can be realized in overall energy consumption, since infrared radiation losses through thermal radiation are not as large with a smaller temperature gradient both between this space and unheated outside air, as well as between the refrigerator and the lunchroom. Economically, electric heat can be compared to other sources of home heating by multiplying the local cost per kilowatt-hour for electricity by the number of kilowatts the heater uses. For example, 1500-watt heater at 12 cents per kilowatt-hour 1.5 x 12 equals 18 cents per hour. When comparing to burning fuel it may be useful to convert kilowatts to BTUs. Industrial electric heating. Electric heating is widely used in industry. Advantages of electric heating methods over other forms include precision control of temperature and distribution of heat energy, combustion not used to develop heat, and the ability to attain temperatures not readily achievable with chemical combustion. Electric heat can be accurately applied at the precise point needed in a process, at high concentration of power per unit area or volume. Electric heating devices can be built in any required size and can be located anywhere within a plant. Electric heating processes are generally clean, quiet, and do not emit much byproduct heat to the surroundings. Electrical heating equipment has a high speed of response, lending it to rapid cycling mass production equipment. The limitations and disadvantages of electric heating in industry include the higher cost of electrical energy compared to direct use of fuel, and the capital cost of both the electric heating apparatus itself and the infrastructure required to deliver large quantities of electrical energy to the point of use. This may be somewhat offset by in-plant efficiency gains in using less energy overall to achieve the same result. Design of an industrial heating system starts with assessment of the temperature required, the amount of heat required, and the feasible modes of transferring heat energy. In addition to conduction, convection and radiation, electrical heating methods can use electric and magnetic fields to heat material. Methods of electric heating include resistance heating, electric arc heating, induction heating, and dielectric heating. In some processes, electric current is directly applied to the workpiece. In other processes, heat is produced within the workpiece by induction or dielectric losses. As well, heat can be produced then transferred to the work by conduction, convection or radiation. Industrial heating processes can be broadly categorized as low temperature, medium temperature, and high temperature. Low temperature processes include baking and drying, curing finishes, soldering, molding and shaping plastics. Medium temperature processes include melting plastics and some non-metals for casting or reshaping, as well as annealing, stress relieving and heat treating metals. High temperature processes include steel making, brazing, welding, casting metals, cutting, smelting and the preparation of some chemicals. See also. References